okay? So you say to yourself, hey, step one, can I use a certain material, right? Here's that chart that I showed you, that table, right? When we were talking about the water service pipe in the same trench with the building sewer. You can't use this table here if you use vitrified clay pipe, remember, but you know what? If I just have a trench for the sewer pipe, not worried about the water, right? Then I could come in here and use any material here according to this table here, because after all, it is titled Building Sewer Pipe. Where do I find this at? Chapter 30. Here's the table number, 3002.2 to be exact. So you say to yourself, gee, Jerry, what type of piping can I use for my building sewer? ABS? This has been eliminated. Somebody check this table. See if that pipe's still in there. Anybody got a code book? If you do, check this table. I think they eliminated this. Asbestos cement pipe. They may have eliminated that. All right. Let me know. I'll keep on going. We could use concrete pipe. We could use PVC. We could use, hey, where's Jamie at? Jamie, are you still with me?
Yes, I am.
All right, look what I could use here for my building sewer pipe. Remember we had that discussion about copper or copper alloy tubing?
Yes.
Wouldn't that be an expensive sewer pipe to be used, copper? Like 3-inch pipe?
I would imagine so.
Yeah, but you know what? I could use K copper, I could use L copper, but you see what's missing here, Jamie? I can't use WK or WL, right? Welded seam cannot be used here. Yeah, very good. It's like
it has been eliminated.
Paul, go ahead.
The asbestos has been eliminated.
Yes, and M has been eliminated too. Yeah, excellent. So as you can see, these are the approved materials that we could use for building sewer pipe. As we go along, and of course, here is the pipe fittings that are associated with those materials, as indicated in this table, still in chapter 30. I'm still given the pipe materials and the pipe standards, and I can still use, in fact, vitrified clay pipe, as you can see, stainless steel, PVC, etc., etc. Now, that's your workbook. You have all this material available to you in the workbook, and I'm going to get into the PowerPoint here and kind of make sense of this. So we've seen that graphic. We know where the building sewer is. We know where the building drain pipe is. They are two different and distinct parts of the drainage system, right? Moving on. There's our tables, building sewer pipe, the pipe fittings. Step 2, we need to make sure that the building sewer can be inspected, making sure that it is not concealed or covered or even put into use. If I'm looking at the approved construction documents, I'm looking at the pipe size, I'm checking the slope to make sure it's sloped accordingly, and I'm checking also protection from freezing, possibly. I don't know. Well, if I go to this section of the code here, it kind of gives me a little bit of insight here. So basically, it's recommended that you check with the authority that has the jurisdiction for building sewer pipe. Now, again, this could be your local engineering department, maybe your city engineering department, county engineering department, maybe the building department. I don't know how your jurisdiction is structured, but in any case, we're just talking about the model code here. There are no amendments to the code that I'm presenting here. This is strictly right out of the International Residential Code, Chapter 30, Section 3001.2. Here it is. Portions of the above grade DWV system, other than vent terminals, shall not be located outside of a building, attics, crawl spaces, etc., unless you protect it from freezing accordingly. Hey, does this look familiar to you? Have you seen this picture before? Carla, smile. Have you seen this picture? Right. We've seen this before. We saw it with the water service pipe, didn't we? And now we're seeing it with respect to the building sewer pipe. It's the same thing. Any type of piping cannot pass below that bearing plane because this is where we resolve the pressures of the building's load into the soil below at the juncture of the footing. Okay, makes sense? Hey, I was on a job, I don't know, a few years ago, and I figured I'd take a picture of this guy. Look at this guy. He was actually putting in the building sewer system way, way up here in Lake County, Ohio, right? So I figured I'm going to take a picture of this because this is a good picture. I mean, it's the same thing. We don't regulate, or we didn't regulate the building sewer in our jurisdiction. I was the building official. We just regulated building stuff, like when it came into the building. However, look what happened here. He put really nice bedding here. Look at that stone. Isn't that nice, right? There's no blocks here. He was waiting for the county to come out, right? Well, he wasn't quite done. He had the trench box in here. He had the pipe. He's just thinking about, man, I got to get the rest of that stone in here and put that bedding in, right? In other words, we need to make sure that when that pipe is placed on the bedding, it is not concealed and it's firm according to this particular section right here, trenching and bedding. We've seen this before, haven't we? For the water service pipe, it's the same for the building sewer, 2604.1. So we're seeing some similarities here, right? I want you to look at this particular table right here. I bring it up here for a reason. If you have a code book, find this table. Find this table, okay? And as you're looking for this in your code book, it's table 3004.1. 3004.1. I want you to look for that in the table, okay? And I'm going to go back a few slides and talk to John. All right, you find that table. I'll get my workbook out. All right. John Baxter, good. John, that was eliminated, wasn't it? That asbestos pipe I saw on this table here, right? Somewhere around here. Yep, it was in the top table here. Yep, right here, asbestos cement pipe. Good, so that was eliminated. Thank you, John. Appreciate that. Great. So this table is giving us the demand, ladies and gentlemen. We could use this drainage fixture unit value as the demand, ladies and gentlemen, for the sewer. We could use this as a demand for the horizontal drain inside the house. We could use this as a demand for any particular type of fixture that you see in this table. Now, is there a definition for drainage fixture unit? Where do we find such a definition? Did John Gibson go over that with you on the first day? He's a great instructor, isn't he? Chapter 2 in the residential code will give you the definition for drainage fixture unit. What do you think it is? Let's have a conversation. Anybody? You can unmute yourself. Go ahead.
The size of the drain.
7.5 gallons.
I'm hearing gallons. I'm hearing drainage. I'm hearing, okay.
7.5 gallons, isn't it?
So coefficient used to determine or to note the demand or the impact the unit has on the system. We use it for sizing
Yeah,
lines.
Chris, I like the way you put that. It's a coefficient. How about if I put it in different terms? How about if I say it's an index, right?
Yeah.
Maybe it's just a number. And the number represents maybe the times that that particular fixture is used, the flow based in, the load on the system as far as how many gallons will flow from that particular fixture down the drain, right? Things of that nature. How many successive uses of that fixture, and then we all combine that stuff. This was actually put together by a guy named Dr. Hunter many, many years ago. We find this still in an engineering document called the ASHRAE Handbook of Fundamentals. This is tried and true. This is empirical data based on his early studies of how things flow hydraulically in our plumbing system, things I say, waste and water as well when we get into the water. But anyway, we're looking for what's called the drainage fixture unit. It's the demand that the fixtures put on the system. Once I figure out how much my demand is, I can size the pipe. Wait a minute, say that again. Once I figure out the demand, I could size the pipe. Oh my gosh, what a concept. Isn't that amazing? We do the same thing with electrical, ladies and gentlemen. If I figure out the ampacity of my circuit, I could size a conductor. We could do the same thing with HVAC. If I find out the volumetric flow in CFM, I can size the duct, right? Based upon the pressure, of course. It's all the same. Give me a demand, I'll size the pipe. That's what we're doing here. Take a look at this. I have types of fixtures over here and the associated demands here. Why am I spending time on this? Because we need to know about this for later applications that I'm going to show you later on today. So let's pick a fixture. Let's say I've got a clothes washer standpipe here. What is my drainage fixture unit for a clothes washer standpipe? I go all the way over to the right-hand side. It's 2 drainage fixture units. Great. How about a lavatory? A lavatory, that's that fancy word for a bathroom sink, right? A lavatory has a drainage fixture unit value, or I should say a demand of 1. Beautiful. So if I have a pipe that comes in and supplies maybe these particular fixtures, maybe I got a pipe that'll supply or take the drainage from my lavatory, maybe a couple other things in the bathroom, like, I don't know, a bathtub perhaps up here at 2. I could size my pipe carrying a bathtub and a lavatory for 3 drainage fixture units. There's tables that we use to size the pipes. But in this case, we're talking about the building sewer. Now, if you recall, the building sewer, ladies and gentlemen, takes the whole demand out of the building, right? If I show you this graphic again, let me go all the way back. I want to put this in perspective for you. Right here. Would you agree, ladies and gentlemen, that the building sewer will take the full demand of the whole house? Is that a fair statement? That's going to take the demand from the water closets, the bathtubs, the kitchen sink, the standpipes, all the way down out of the building. I need to design my pipe for the full demand, no diversity, okay? If I say that, we know where the demand table is, we could kind of calculate all that stuff and maybe reference a table prescriptively and deal with it. So let's have an application before we break for lunch here, okay? Examine the slope of a building sewer to be sure it's either 1/8 inch, 1/4 inch, or 1/2 inch per foot minimum as applicable. Now, I've given you a table number here, okay? I've given you a table number. Here's your table number. If you have a code book, see if you can find that table, okay? If not, I'll show you where that's at, okay? As you look in your code book for that particular table, I'm going to kind of advance here and get this graphic up because I'm going to switch back and forth and ask you a few questions. So if I'm a plans examiner in a building department, or if I'm an engineer designing the system, or if I'm an inspector, I think I should know a little bit about plumbing. How about you? If I aspire to be a plumbing inspector, yeah, I would say true. I want you to look at this graphic. Look at the type of fixtures I have here. You see this? I got a shower, I got a lavatory, I got a water closet. Anytime that you have a water closet, you're probably into a bigger pipe size, right? Than say a lavatory or a shower. I'm going to make another statement here, and I'm going to say that you can never, ever reduce the flow or reduce the pipe size in the direction of flow. I'll say that again. You can never, ever reduce the pipe size in a drainage system in the direction of flow, period, end of story. There's only 2 exceptions, and I'll show you where they're at, okay? Remember that. The pipe size must remain as large as possible period, all the way out of the system. Now, what did we show you here? We showed you some of the fixtures here. We showed you that I've got a building drain here, and the full demand of the system dumps, of course, into the building sewer. So here's our application, ladies and gentlemen. Well, examine the slope of the building sewer. All right, so we come in here and we say, okay, let's look at the table. If you found that table in your code book, this is what you're going to find right here. Okay. Now let's say I'm going to bring up an example for you. I'm going to first read the table to make sure I'm in the right table. I don't know if you're like me, I pick the wrong table periodically. It's embarrassing, but I catch myself every once in a while. You need to look at the table. This table is for the maximum number of fixture units. They should say drainage fixture units allowed to be connected to what? The building drain branches, or here's where we're at, the building sewer. Hey, I'm in the right table. Now, the left-hand side of the table is my pipe diameter in inches. And as you can see, it starts at 1.5 inches. It finishes with 4 inch. The slope per foot is given to you at 1/8 inch slope downward per foot of pipe horizontally, 1/4 inch or 1/2 inch. Now, I'm going to give you an example. If I go back to my graphic here, right here, go back to my graphic right here. You see my graphic right here? Let's say that I calculated a demand flow on my building sewer all the way down here for a total demand of the system of 19 drainage fixture units. You with me? My whole house calculates to 19 drainage fixture units. Now look here. I've got a water closet here, 1 toilet. I've got a lavatory, a shower, maybe a couple other things here, laundry tray.
Yeah, there is. There's both. Yep.
Things of that nature. All right. So you're with me, right? So 19 drainage fixture units. Let's size the building sewer. And I want to size the building sewer based on a slope of 1/8 inch per foot. That means it's going to pitch downward 1/8 of an inch per linear foot of horizontal length. Okay? 19 drainage fixture units, 1/8 inch per foot. So we come in here, right? I come in here and I say, okay, well, let's see, 1/8 inch, okay, 36. Well, wait a minute. That puts me at a 3 inch pipe. That'll carry the demand. My demand's only 19 though. Well, wait a minute. Let me go to 1/4 inch. What if I went to 1/4 inch slope, which I can do? Look at this. A 2 inch pipe will handle 21 drainage fixture units. I told you that the demand for my house here is 19 drainage fixture units.
So, no water closet though.
Well, say that again. What?
No water closet.
What do you mean no water closets? I got a water closet right here, Francisco.
Yeah,
I got a water closet right here.
Footnote. Look at the footnote.
Oh, there's a footnote?
Yeah, you got to
Oh, man, I think you're exactly right. Look at the footnote. Francisco, you get the gold star for the day, right? Everybody look at the footnote. They're a application of the table. You are never, ever allowed to use water closets when you see footnote B. You see what happens here? Your water closets here have an outlet of 3 inch or maybe even 4 inches sometimes, but normally they're 3 inches accordingly. Case in point, I need to use a 3 inch pipe. So it goes back to my original design here. If I slope it at 1/8 inch per foot, I can carry 36 drainage fixture units, but the minimum size pipe that I could possibly use on any single or 2-family house is a 3 inch, provided you have water closets. Does that make sense? Okay. We used a table here to take a demand and size the building sewer system. And Francisco, there you are right there. You're exactly right. You always, always read the footnotes accordingly. All right. Let me just take care of one other thing here. Here's our trench again here, making sure that we have those 6 layers tamped. That's exactly like we found in the water service pipe. So we'll finish up with a question or two here, and then we'll go to lunch. Question number 1, can sewer piping be supported on rocks within a trench? Can sewer piping be supported on rocks within a trench? Absolutely not. And there's our code section. Do you see it's coming up like a bad habit all the time, the same code section? 2604.1. I want to go on Jeopardy, you know, and they're going to ask me, Jerry, can sewer piping be supported on rocks? I'm going to say absolutely not, right? Because Don told me to go to chapter 26, specifically 2604.1. There we have it. How about this one? All right. Ooh, this is a good question here. If you have the table in front of you, what is the maximum drainage fixture units permitted for a 3-inch building sewer pipe if I'm sloping not 1/8 inch, but a 1/4 inch per foot? Do you have that table available to you?
42.
42.
Yeah, is it A21, B27, C42?
42.
C, 42.
All right, I'm with you. Let me get that table up here. Let me click this, see if I got the table. There we go, right there. There's the table right there. Simply 1/4 inch intersected with the 3-inch pipe. You have the capacity, the demand capacity of 42 drainage fixture units. Great, excellent. Last but not least, you have a checklist at the back of your workbook. Utilize this if you're a building official, plumbing inspector, plans examiner, et cetera, et cetera. Again, we have all the little code sections embedded here based upon the inspection task or the plan review task for that matter. Man, that puts us perfectly right at this portion to discuss after lunch. I think it's lunchtime, don't you?